Welcome to the webinar on alarm management, getting the most out of your Siemens PCS7 control system. You'll all be on mute during the webinar. If you have any questions or comments, please enter them into the questions box. We'll try and get them at the end or via email. So my name is Todd Stauffer. I'm the Director of Alarm Management here at Exida. I'm responsible for products, services, and training, and have been involved in alarm management for quite a while, including participating in the ISA 18.2 Standard Development Committee since 2005, or actually prior to 2005. And I'm an editor and voting member, so that means I got to actually write portions of that standard. So I'm very familiar with what's in it and what it means. Also got to participate in some of the follow-up activities, including co-chairing a couple of technical report activities. And if you have never been on one of these webinars before, a little bit about Exida. We were founded over 20 years ago with a vision to make the world a safer place, primarily process plants, applying functional safety. That vision expanded years ago to include other risk factors in a process plant, such as cybersecurity and alarm management. We're well known for certification, that is both for people and processes and products as well. In particular, if you've ever worked with a safety instrumented system and put in SIL rated equipment, chances are it was Exida that did that SIL assessment. We've done more of those than any other company in the world. We have a suite of software, of engineering software, to help users comply and follow the functional safety lifecycle. And that software is called Excelentia. One of the modules in Excelentia is a tool for alarm management, alarm rationalization in particular, and it is called SIL Alarm. And we'll talk a little bit about that during this webinar. So what are we going to talk about? Well, we're going to look at the PCS7 control system and the alarm management functionality that's present there. And what we want to do is to kind of go through some features and functions that can really help operators respond to alarms and improve their performance, and understand the pros and cons of using the functionality, how to possibly configure it. And then we'll also look at some of the specific tools, either from Siemens or embedded within PCS7 or third parties that deliver that functionality. One of the underlying themes of this will be, though, we can't just assume that by enabling a function within the control system that everybody will understand how to use it. So as we roll out new capabilities, we need to be mindful that operators in particular need to be trained on how to use it, what the tools will do, and all that kind of good stuff. So let's start. What are the most common alarm management issues for a site that has not done much alarm management yet? Typical, you would have too many alarms, and that could be on a steady state basis as well as transient after an upset. Nuisance alarms are another kind of universal problem. There's different categories of nuisance alarms. Chattering alarms is one of them. Stale alarms is another. And then there's a category called bad actors or frequently occurring alarms. And we'll talk about them shortly. In addition, sometimes the alarm priority is not meaningful. And we'll talk about that, what that means, how important that is, and ways to change that. So if you have these alarm management issues in your system, then you're going to make it harder for the operators. And you could essentially take the alarm system, which should be a very valuable tool to help the operators do their job. You can take that and turn that into something that's not valuable at all, or could actually be a net negative toward the operator, could actually have a negative impact. So all the more reason why we really want to focus on getting rid of these alarm management issues. Now, to guide us in that journey, we have alarm management standards and guidelines to draw from. The MUA 191 guideline was the first in the alarm management world that came out in 1999, actually in response to the Milford Haven explosion, which we will talk about shortly. Then in 2009, the ISA committee released the 18.2 standard on alarm management, primarily focused on the US. Then in 2014, the same leadership team, Donald Dunn and Nick Sands, worked with the IEC to get a international alarm management standard published. That's the IEC 62682. And these two are largely the same, largely have the same content. In some cases, some specific differences depending upon the opinions and thoughts of the individual teams involved. But because it's the same leadership team, on purpose, trying to keep them as synchronized and consistent as possible. Now, the ISA standard would be considered RAGAGAP, recognized and generally accepted good engineering practice in the US. So if you are required to follow RAGAGAP, like if you were complying with the OSHA process safety management regulation, then that standard is what you should be following. Both of those standards describe what's called an alarm management life cycle. You can see that in the upper right-hand corner here. And that's really a workflow process. So for the different tasks in the alarm management life cycle or an alarm management program, it kind of lays out what needs to be done and when it needs to be done. Another important element in the standards is the definition of an alarm, and essentially determination of what an alarm is supposed to be. So let's look at that definition. An alarm is supposed to be an audible and or visual means of indicating to the operator, and I underline the word operator as being important. Why would I do that? Well, the reason is because the operator is the target audience for the alarm system. They're the user. So that means all of the messages that go through the alarm system need to be understandable and actionable by the operator, or else they don't belong in the alarm system. Second point, an alarm is an equipment malfunction, process deviation, or other abnormal condition. Why would I highlight abnormal condition? Because an alarm is supposed to indicate that something is wrong, something unexpected has occurred. And then last but not least, it requires a timely response. And I don't mean silencing the horn or acknowledging an alarm. They don't count. They don't actually correct the problem. So we mean things like opening a valve, turning on a backup pump, something that will actually correct the situation. Now, the process of alarm rationalization, which is something we're going to talk about a little bit, is essentially going through the alarms in your system and making sure that they meet this definition of an alarm. And by judging against them, against this criteria, you can actually weed out the points that should not be an alarm, thus cleaning up your alarm system and improving the performance. One of the typical reasons why folks have poor alarm system performance, too many alarms, is that they use the alarm system to communicate everything that the operator needs to know, whether it's a true alarm according to this matrix or not. So it actually makes sense to think a little differently and say, well, if it's not a true alarm, let's create other categories for that and then display those non-alarms separately than true alarms. And if we can eliminate any intermixing of them, then when an operator gets an alarm or some kind of notification within the alarm summary display, they know that it is an alarm that it's an abnormal situation and that it requires their action. So there's no hesitation as to whether it's something they need to respond to or whether it's something that's just for informational purposes. You can display them in alternate views. There's actually a activity going on right now. One of the working groups within the 18.2 committee is chartered with writing a technical report on how to deal with these non-alarms. So how to best deal with alerts, prompts, and messages. Now, in this presentation, we're going to go back and forth between talking about alarm management functionality using the ISO 18 and IEC terminology. So things like alarm shelving, but then we'll also talk about the analogous term from PCS7 vocabulary, which would be, in this case, manual alarm hiding. So I'll always try and make that connection so that you can tell when something is being talked about in the standard as in this generic term, how it actually applies directly to a PCS7 system. So let's get started. Now, rather than just kind of throwing out, here's some cool features to think about, which wouldn't necessarily be very helpful in understanding how it all goes together and what it can really do for you. What we're going to do is to talk about some selected features from the framework of an overall alarm management program. And in this case, this is the one that Exida uses. It's derived from the alarm management lifecycle, and it essentially consists of these 7 steps, which you can see here, with the first one being doing some initial performance benchmarking. Next, creating an alarm philosophy document, and then see alarm rationalization after that. So we're going to walk through each of these stages for completeness, and then we're going to talk about the tools and capabilities within PCS7 that help you achieve the goals therein. So let's get started with step number 1, initial performance benchmarking. And what we want to do is benchmark the performance of the alarm system from a quantitative and qualitative point of view. From a quantitative point of view, that means let's calculate things like the number of alarms that the operators get on average. Because in the standards, we have recommended metrics and a set of KPIs to judge performance against. So it makes sense to have a performance evaluation tool that will automatically calculate your as found or as performed metrics so that you can directly compare them to what's in the standard or what's in your philosophy. And that will help you know some of your key battles to be fought. And then you can trend that over time to see how your KPIs are changing, hopefully in the positive direction. Another thing that these tools can do, or another key capability to take advantage of, is to create individual reports that highlight alarms that fall into those alarm management issues categories that we talked about. So bad actors was one of the categories. And here's an example of a bad actors report. It's essentially identifying specific alarm conditions. And what's exciting about this is you may have 10,000 alarms configured in your PCS7 system. But what this report is able to do is to identify the 10 alarm conditions that provide the most notifications to the operator. In this case, almost 44%. So that's a huge impact on performance just from that small set of alarms. And something is most likely wrong with them because of the number of times they're going off. So if you can focus on fixing them, called bad actor resolution, then you can directly impact alarm system performance in a significant way. And you can use it for continuous improvement. There are other areas that tools should ideally be able to focus in on. This is a snapshot of the Siemens PEA tool. And in this case, it's identifying alarm floods, talking about the percent of time that it was in flood. Also, it can identify stale alarms, so alarms that have been active for, let's say, more than 24 hours. So really not doing a useful job, or not there to help trigger or capture an upset condition. So those are some third-party software and Siemens software. In addition, one of the things that makes PCS7 unique is that it has some built-in performance software in it. So you don't need to do anything. You don't need to purchase a license. You don't need to pay any extra money. It's built in, and it's been built in for a long period of time. So there is a display from the journal list where you can look and you can see which alarms have been active for the longest. So essentially identifying your stale alarms. So you've got built-in tools that you could walk out today, requires no configuration, and start using them to identify your alarm performance problems so that they can be fixed. Now that's quantitative assessments. There's also qualitative assessments, meaning let's talk with the operators to get their input on what is working well within the alarm system and what's not working so well. And that could be functionality. It could also be processes and procedures as well. So it's not just numerical performance measurements. It's, hey, is the system really doing the things it needs to support you, Mr. Operator, as you are the target audience? So things like, do alarms appear for equipment that's not operating? Let's say that it's not being used. Well, that would be a significant scenario to identify significant source of nuisance alarms. So, and we have a questionnaire that can be used to do this, both an electronic version, standalone, and a form on the internet. So feel free to follow up with us afterwards if you're interested in learning more. Another thing that we've just developed for PCS7 systems in particular is a functionality audit questionnaire or checklist. It's meant to be a self-assessment. And what it's meant to do is to somewhat provide an educational list of what are the key alarm management functions within PCS7 so that you can go through and identify whether you're using it or whether you're not, and whether you would like to potentially use it in the future and what the plan might be to get there. So here's some examples of things that we're actually going to look at today: the use of or definition of safety alarms, the locking of alarm messages, essentially suppression of messages, and the use of alarm shelving. So that kind of stuff is built into this questionnaire, which then can be used to help identify things that you want to change in your PCS7 system, or to identify scenarios that you want to get clearer upon or update in your alarm philosophy document. So now let's talk about step 2, which is creating the alarm philosophy. Philosophy is the guideline for how to do alarm management at your site. There are specific topical areas that should be covered in your philosophy. And here's the list of those topics. You can see how the list has changed over time as newer versions of the standards have come out. We are in the process of revising and updating the 18.2 standard, and I believe it will come out later this year, 2022, as a newer version. And I don't think there are any additions to the list of content. The last time I saw what was happening, there was none. So in this list are things like, how do you prioritize alarms, operator training on alarms, use of alarm response procedures, and alarm shelving. Those are two that we're actually going to talk about here and related to PCS7. So if we look across, we see that One of them is required and one of them is recommended. What does that mean? Does that mean we need to use that stuff? No, it doesn't. In this case, it means if it's required, it means you should have a section in your alarm philosophy that talks about how you will use alarm response procedures. And it could be, we do not intend to use alarm response procedures, and that would be sufficient. You have identified whether you're going to use them or how you're going to use them. So that's the purpose of this list, is to get you to think about some core areas related to alarm management and to kind of document your expectations on what you will do in that area and how you will use the functionality of your control system. One of the most important things is to determine how you're going to prioritize alarms. And priority is an attribute of an alarm that helps the operator know the relative importance of that particular alarm compared to others. Typically, alarms are prioritized based on analyzing the severity of the consequences. So how bad would the consequence be that's going to happen if the operator doesn't respond? And how much time do they have to respond? The combination of that typically dictates the priority. So what priority is for is to help the operator know when there are multiple alarms present at the same time, and when is that not true, that they know which one to respond to first. The higher priority alarm is the one that should be responded to first, the one that typically might have the more severe consequences. So that's what priority is supposed to be used for. Now, you could set up your priority scheme in PCS7 like this. Priority runs from a numerical value of 16, which is the highest, down to a low of 0, which is essentially the default. Many PCS7 configurations that I have seen have the alarm priorities all set to 0, which means that they have not been changed from the default, and there is no direction being provided to the operator in terms of which alarm is more important than another, at least not by priority. We'll see some other ways that that information is kind of delivered. But one of the takeaways hopefully would be, if you have not done any prioritization or rationalization, that you should think about doing that so that you can assign priorities in a way that's usable by the operator. Because having all your alarms left at priority 0 means you are wasting a capability for the operator that they need to help them respond. And what do I mean by that? Well, here's an example where it made a big difference. The Milford Haven refinery explosion in 1994. They were struck by lightning in the summer, caused some fires. So the operators were shutting down the process, keeping certain portions of the process active, and they ultimately overfilled this flare knockout drum to the point that fluid released, ruptured a pipe, and we had an explosion and more fires. Now, one of the reasons why that occurred, or when they investigated what happened, they saw that there had been a high level alarm for the knockout drum, and it was enunciated to the operator. So there's a safety critical alarm that went off, but the operators missed it. Understandable, though, considering that it occurred in the midst of an alarm flood of 275 alarms in 11 minutes. That's a new alarm coming in every 2 to 3 seconds. So imagine putting yourself in the operator's shoes, staring at an alarm summary where a new alarm is coming in every 2 seconds, and trying to keep that in mind and understand what's happening, keep visibility to the most important alarms, and know what to do. That was very challenging. it would have been challenging for anybody. But it was made even more challenging because all of the alarms were the same priority. So there was no way for the operator to easily say, okay, I got to keep my eyes on these two because they're the critical alarms. So even though this safety alarm related to the knockout drum level went off, the operators essentially missed it because it didn't stand out. It was the same priority as every other alarm. So during the investigation, the HSE in the United Kingdom, one of their takeaways was, lesson learned, safety critical alarms should be very obvious, very visible. They should be distinguishable from other operational alarms so that the operator always has a handle on whether there is a safety critical alarm present or active. That would have hopefully helped in this particular situation. So what does that mean in PCS 7? Well, PCS 7 is designed so that the highest priority alarm, priority 16, or alarms of priority 16, anytime one of those occurs, and hopefully it's infrequent, it would turn this symbol active in the alarm banner. So the operator has a single place to look to know whether there's any safety critical alarms active. And then they can click on that and call up a display that has just safety critical alarms, just the alarms of that priority 16. So pretty useful capability, and one that provides that visibility to safety alarms that the UK HSE was asking for. But guess what? If you have all your priorities left at 0 for all of your alarms, guess what functionality is not going to work? This functionality. So unless you go through rationalization and prioritization and set priorities of alarms, including some to priority 16, this very useful capability is not going to be active in your system. So now let's talk more about priority in PCS 7. In older PCS 7, the criticality of the alarm was basically based on the message class, which you see here, which is kind of like the alarm type, and its priority, where the priority was set during rationalization. Now, built into the system was kind of a behind the scenes rule set that said each alarm type, or called a message class, has an inherent importance, has an inherent spot in the pecking order. And what I mean is an alarm high is by definition in PCS 7 more important than a warning high, which is more important than a tolerance high, which is more important than a diagnostic message. So that was built into the system. And what that means then is the importance of an alarm is really dependent on the alarm type. So any alarm high or low type of alarm, because the system assumes that that's the most important, those would always be colored red on the HMI and within the alarm summary display. A warning high alarm would be yellow because it's not deemed as important as the alarm high. And you see that in this chiclet here, where the alarm icon box is the first one to occur. So it's showing you that it thinks that that is more important. So that works pretty well for some systems and some applications in the way people choose to prioritize alarms. But let's take a look at a particular example. And this is looking at high level alarms in a tank. So let's take a high, we'll call it a high and a high high. We'll take a high alarm and we want that to be a pre-trip alarm that's going to activate at 80%. And then we have a high high alarm that'll activate at 90% and will actually indicate that an interlock has activated. Now, when we go through rationalization, because the consequence, let's say, of tripping the interlock is significant interruption to production, the high priority, the high alarm, which is the one that actually gives the opportunity to the operator to prevent that interlock activation, will turn out to be more important. It should be assigned a higher priority than the high alarm, which basically just says, oh, the trip has occurred. Now go restart or prevent stuff from propagating upstream and downstream. So based on following the principles of alarm management, we might have that the high alarm is actually more important than the high. So let's say we assign priority accordingly, and we give the high alarm, which would be a warning high type, we give it a priority 10, and the other alarm we give a priority 7. So the warning has the higher priority, but because of its alarm type, it's treated as not as important as the interlock has activated alarm. So the warning high would be yellow, even though it has the higher priority. So that would be kind of problematic and inconsistent if you were prioritizing alarms in this way. So what Siemens did is said, okay, well, we need to provide some flexibility for users to change the way kind of the importance of an alarm is identified and how that works. So they decided to call the original way, the default, the classic messaging system. And then they defined a new way called the user-defined messaging system. And the big difference between the two is you can actually customize what you call the message types or the message classes. So instead of alarm high and alarm low, we can change it to critical, high, medium, and low, things that you might expect to be used when assigning the priority of an alarm. So that means now we have broken the connection between alarm type per se and importance. Now we set, for each alarm, we set what this message type name is, and that directly aligns with a specific importance. So the critical priority, if you want to call it that, would be importance number 1. The high priority, no matter what type it is, no matter what alarm type it is, would be the second highest in importance. And that would be a very different way of aligning and ordering alarms, and would be a way that some people would consider better than the classic messaging system. So if you use that new approach, which is available in PCS 7 version 8.0 Service Pack 1 and later, then you can implement this capability. In addition to custom defining what priority and names you want to use, you can also set the abbreviations, which control what shows up in the little chiclets. So in the original system, you have A's and W's and T's for alarms, warnings, and tolerances. In this case, you could change that to be numerical to line up with the importance, or you could use text as well. So we could use a C as the abbreviation for critical, an H for high, etc. You get the idea. So user-defined messaging system, the chiclets might be displayed like this, where we're showing that's an alarm that's of priority or importance number 4, or that is of a low priority, low importance. Very different from the classic system. What does that mean to rationalization or assigning the priority? In the classic message system, you set essentially the priority attribute by changing it numerically from 0 to 16. With the user-defined messaging system, you would actually change the message class assignment instead, and you would set it to one of those priority names that we had defined earlier. So critical, warning, or critical, medium, high, low, or whatever you want to do, that's how you would assign it. So that would link to the importance and thus the priority of the alarm. So this is an example of how you might define all of the message classes in PCS7 if you want to use it as part of this secondary priority approach, user-defined messages. And when we look in this, we can see, hey, there's an alert and there's a message and a prompt you could put in here. So you could actually very easily set up your PCS7 system to differentiate true alarms from non-alarms and present it in a different way to the operators. Now, one of the benefits of using the user-defined message system is it's designed to kind of automatically propagate whatever customization you do to propagate it to all the HMI elements. So faceplates will update, colors will update there. The alarm summary display, as you can see here, updates to reflect that stuff. So it's kind of designed to allow the behavior to be tailored to what you want. So now let's turn to look at alarm summary displays. So these are the lists of alarms that operators can look at. And they may have it displayed constantly to help them know what's going on. There are many different alarm summary displays that contain different types of alarms, contains different states, for example, unacknowledged or acknowledged, also contains historical events, that's what's in the journal list. And then here's one, a special list for locking. As we're going to see later on, locking is a form of alarm suppression. So when alarms are locked, they go onto this lock list. So there is a dedicated message list for showing alarms that have been suppressed by locking. Another thing we'll notice here is that in the journal list, this little icon here will actually call up the hit list tool in PCS7 to help us do some analysis of what alarms need to be fixed, the bad actor list. So the purpose of going through this is there are a lot of predefined message lists in PCS7. You should look at them and make sure that they display the information that you want and that they behave the way you want, and operators can utilize them in a way that makes sense. So what do I mean by that? Well, the default that the operators will see is what's called the incoming alarm list. And that shows pretty much every message class. So it shows alarms and non-alarms, including diagnostics. So you might want to try and move some of those out of there. But also notice that it shows alarms that have not yet been acknowledged. So what that means is a new alarm comes in, it shows up on that screen. The operator acknowledges the alarm as part of the acceptance of it or to indicate that they've acted upon it. And then that alarm disappears and goes to a different list. And that might be exactly the way you want it to work. Or if you want to provide the ability for the operator to continue to monitor the alarm to see whether it's gone away in result of their action, then they would actually have to go to a totally different list to check that. So perhaps you might find that it would be better from the operator's point of view to display both acknowledged and unacknowledged alarms together. That would be this list of active messages. So you could change that to be the standard list that shows up. And in that case, it's going to show both acknowledged and unacknowledged. So even when the operator acknowledges the alarm, it stays within that screen. So not only do they see what's new and fresh, but also they can monitor to see the alarms disappear, hopefully, a couple minutes after they've taken the appropriate corrective action. So that's why it's worth looking at the message lists and what they do. They are very configurable, meant to be that way. Some of the configuration can occur from the OS configuration tool or from the user-defined messages tool. Or in addition, each alarm summary list has a different picture file that is used. So you can go to that picture file and edit that particular picture, that instance of it, and change the behavior in a way that you would like, or that makes it more acceptable to operators. You could even use these then as a starting point and create a new additional alarm list that you define according to your desires or requirements, and to display whatever in particular you want to. So it has a lot of flexibility built in. Now, the selection of whether you're using the classic message system or the user configurable will drive the order that the alarms are presented. So here you can see a little description about the differences there. The classic message system basically is designed to show alarms based on the date timestamp. The user configurable messages is defined to set the list of alarms in order based on the importance, critical, high, medium, low, and the date timestamp. So this, if used correctly, is a very effective way at helping to keep the most important, highest priority alarms at the top in the operator's view. So being able to order your alarms following both the importance and date timestamp can make it more effective for the operators, makes it easier for them to deal with alarm floods. So the system is somewhat configurable in these aspects, as I mentioned, from the OS editor. Some things can be set there, as well as within the picture itself. One of the no-brainer type things within PCS7 is from the alarm summary displays. You can click in what's called the loop and alarm button, and it'll call up either the faceplate or the process graphic that contains the point and the alarm. So I've seen some scenarios where this function is not used, or it's used to call up a faceplate. Well, it's pretty valuable and pretty useful to the operator to have a single click ability to be taken to the process graphic that contains the alarm, because that's where they can look at all the other related things and related measurements that are going on related to that alarm to have a better assessment of what's happening and what they should do. So using loop and alarm and having it call up a process graphic is pretty much a no-brainer to me. And if this is something that you're not using yet, then definitely consider how you could possibly take advantage of it. So now let's jump into 2.1, bad actor knockdown, something I don't usually talk about because usually we focus just on rationalization. But in this case, we're going to use this intermittent or intermediate bad actor step to go through some stuff. So here is what's called the hit list in PCS7. It is a view of the journal list that shows essentially a Pareto of alarms, telling you which ones occurred most frequently and what their average activation time was and things like that. So you can identify chattering alarms through this, you can identify stale alarms, and you can identify your bad actors. So again, this is a tool that's built into PCS7 that just works out of the box. So you could go down to your system right now, not knowing whether anybody has ever used this, call up the journal, and then start to see this information. And right there, you have an identification of alarms that probably need some TLC. So that would mean go through a remediation procedure of some sort, follow some kind of remediation process. And we've got a document to help folks do that, where based on the identification of what issue it is, you look at the techniques that you can use to apply, such as deadband, on-off delays. So if it was a chattering alarm in particular, those would be good candidates. But now let's look at the PCS7 alarm libraries to see how that manifests itself. And if you're working with the older library, either called the basic library or the technological library, it's had different names over the years, you'll see that, as an example, an analog indicator point can create 5 different alarms. It has a deadband, but it doesn't have on delay or off delay. That was not supported or provided in the library. So if on delay and off delay were tools that you needed to help get rid of those bad actors, you're kind of out of luck with this library. You'd either have to build that in custom, or you could switch to using the advanced process library, which has a series of modules provided that have built-in capabilities similar, but much more. So you've got more alarm conditions, including rate of change. You've got the ability to have the alarm, if it's not being used, actually removed altogether from the faceplate. It's got a separate disable that impacts annunciation to the operator. So if you wanted to use an alarm to trigger an interlock, you could separately say, I want this alarm created, but not enunciated to the operator, and you could use it for that consequential logic. Most important to this discussion, though, is it supports on delays and off delays in addition to deadband. So you could use the APL library to more effectively deal with some of those alarm management issues. And based on something that's called a feature bit, it actually provides different pre-canned functionality. So if this one particular feature bit is set to a 0, then the on delays and off delays would be the same for alarm high and alarm low. If it's set to a 1, then there would be separate and distinct on and off delays for every alarm condition, every analog alarm condition. So to your heart's content, you can define different on-off delays. So the use of different libraries definitely impacts what you can do from an alarm management point of view. So now let's talk about alarm rationalization. We want to create a master alarm database first. So how do we do that? Well, the alarm information can be extracted from the process object view from a couple of the different tabs, such as blocks, parameters, and messages. We can export that, and then we can kind of combine, glob together those 3 files into something that's coherent that we can then load into our rationalization tool, which is called SOAlarm. You'll find that some of the alarm configuration resides in the messages, some in the parameters, and some naming in the block. So you really do kind of need to pull stuff from each of those 3 and put it all together to completely characterize one alarm. So this is something that we do with PCS7 system, and then when the rationalization is complete, we go in the reverse direction, and then you could import these files back into PCS7 to update the configuration. Now, the rationalization process, we're looking to make sure each alarm meets the definition of an alarm that we talked about. So part of the way we do that is by defining what the consequence would be if the alarm is not responded to, what the corrective actions would be, the likely causes, etc. Now, what's significant about consequence? Well, if there is no consequence, it shouldn't be an alarm. And if you can't define a corrective action, it also shouldn't be an alarm. But for a true alarm, we'll be able to document this information here. And in this case, we're showing it documented in the SOAlarm tool. Then we can make that information available and have it show up and be displayed in PCS7's Alarm Help tool, which is available in version 9 and later. So directly from rationalization, we can kind of harvest that result and make it available. So what does this mean? So rationalization typically involves some of your most senior knowledgeable operators taking part in the process and lending their knowledge and talents to help document for each alarm what they would do. So if you document that in SOAlarm, we can push that into Alarm Help in PCS7, and now every operator can see through this faceplate what your most senior operator would do if that alarm occurred. So rationalization becomes a knowledge capture process. We'll look more at that shortly. Other steps in the rationalization process: setting classification, identifying whether the alarm is used as a protection layer or a safeguard, assigning alarm priority, determining priority based on evaluating how bad the consequence is or the time to respond, done in this example numerically, or we could manually override and set the priority according to a rule. So those are just some of the rationalization steps and how they manifest themselves in the SoAlarm tool. When we're all done, this is the information that you should have documented in your master alarm database. Things like operator action, consequence, response time, probable cause. So the takeaway here is, to do rationalization correctly, you need to think about and document this stuff anyway. Well, if you do it right, then take that documented information and make it available within the HMI to the operators. And you've created a very valuable job aid to help them respond correctly. So now let's look at the creation of those alarm help procedures. So we want something that the operators can look at to kind of tickle their memory, to help them know, hey, what's this alarm for again? You know, maybe it's one that they haven't seen for a couple of years, so it's not one that's fresh in their memory. So they can use it for that. And how does it work? Well, an alarm occurs, and from the alarm summary display or from an alarm faceplate, you'll see this little info box. Well, the operator can click on that and it will call up the alarm help faceplate to show them the information that came from rationalization. So what are the likely causes of the alarm? What's the recommended action? And what's really cool about this is it's right in the context of responding to the alarm. No additional work is required. No additional time is required to get this. So it's not like the operator needs to get up from their seat, go find this 3-ring binder and leaf through it until they find the appropriate alarm. No way. This is right there in context based on the alarm that's actually occurred and what they have selected. So if we capture that information in SoAlarm during rationalization, then when we export to take the rationalization results back into PCS7, part of the format of that file will be to populate alarm help. Now, if you are not yet at PCS7 version 9, which is where alarm help was introduced, there's kind of a little sister to it called the info text box. And that can show one piece of information related to alarm management. So you can actually, if you go through and you do the thorough rationalization, you've documented everything that you need to be able to populate alarm help when you migrate to version 9. So you wouldn't need to do rationalization again because you've documented what you need to. So it would just be a matter of exporting and importing that to populate those faceplates. Moving pretty quickly here. So now let's talk about some advanced alarming, design suppression, and some of the other forms of suppression, shelving and out of service. And these come into play in the context of scenarios where the alarms are not working the way the operator would like. So either you have devices being commissioned or some that require maintenance, or maybe they're undergoing maintenance, or perhaps you have a piece of equipment that's not in use, or you've got an alarm flood that's going to occur, or the last scenario is, nuisance alarms. So perhaps the operator is dealing with chattering alarms. Without using the tools, you might not do anything specific. You might make the operator kind of just try and ignore the nuisance result of these alarms being present. And that's not good for their performance and concentration. So that's what alarm suppression is for. And alarm suppression is the idea that we're going to prevent the alarm indication or enunciation from being presented to the operator when the base alarm condition is present. So the conditions for the alarm are there, or we're not going to show the operator. And there's 3 different types of suppression. There's design suppression, which means the logic has been configured to automatically detect a specific state, and then once that state is detected, to suppress a certain group of alarms. That's smart alarming, but you have to configure the smarts, and that is called automatic alarm hiding in PCS 7. Second type of suppression is called shelving. Now that's meant to be a tool for the operator to use, for example, when they have a nuisance alarm, to kind of temporarily remove the alarm from view so that it can be fixed or it can be addressed. That's called manual alarm hiding in PCS 7. And then the last form is called out of service. This is essentially suppression when the device needs maintenance. So perhaps all the alarms from the device would be suppressed. And this is called locking in PCS 7. So all 3 of these types of suppression are supported. When it comes to shelving, this is something that's different from enabling or disabling the alarm, because when the operator shelves the alarm, it goes away temporarily for a fixed period of time. And it doesn't actually disappear. It goes from the active alarm list to a suppressed alarm list. So the operator can always see that alarm and go find it and unsuppress it if need be. But what this function does is allow operators to better be able to manage nuisance alarms and get them out of their view so that they can be fixed, or you can write a maintenance work order or whatever. So within PCS 7, this shelving capability is provided. It's a single timer that would be used for every alarm, so it's system-wide. So you could, for example, set it to allow shelving of 30-minute duration. That's what's shown here. That is adjustable up to just below 10 days. So you definitely want to think about potentially using this and how you would use it, and when it makes sense to be used, whether there's any special authorization required, and capture all that in your alarm philosophy. Now, if alarms and the associated hardware are not working and require maintenance, then we want to take the device out of service. So you can do that from a faceplate, and that will essentially suppress all of the alarms that come from this particular tag or this particular device. And that's called locking. Those alarms will then appear on the locked alarm list. So this is very useful capability, but of course we would need to train the operations and maintenance team that when we suppress an alarm for maintenance, we use this locking functionality, and then we monitor and look at the locked alarm list to kind of track when things are in maintenance mode and when they're removed out of maintenance mode. And sometimes when you start the remediation process or the alarm rationalization process, you quickly find that one of the major sources of problems is alarms for devices that aren't working correctly. And you need to leverage this locking capability to help you fix those alarms and get them out of the operator's view. Now, there's also a more powerful form of locking that works for more than just one tag. And it essentially understands the hierarchical structure that is created in PCS 7 and allows you, for example, from this particular process graphic, from this picture, PCS 7 knows what tags and alarms are associated with it. So if you lock those alarms, it would suppress every single alarm that's on this graphic or a lower level graphic, a child graphic. So that's potentially very useful if you're taking whole units out of service or not using them. But one of the constraints, one of the things to think about is, are there scenarios where there are still one or two alarms that need to remain active? So if you've got safety alarms, let's say for high pressure in the reactor, and all the alarms can be suppressed, but these one or two alarms still need to remain, that's hard to do if you're using this locking. So that might mean that you couldn't use this area-based locking in that circumstance. In that case, you might be better using a design suppression methodology. And the way that works, there's really two steps to it. First, we define a state detection algorithm. So what are the conditions that must be present to indicate the state? And then what do we want to do with the alarms? Which alarms need to be suppressed or have something else occur? Now in PCS7, it supports design suppression. It's actually called automatic alarm hiding. There's good details on how to set this up in one of the technical support entries. But basically, the way it works is you can define up to 32 states for a given alarm. And what we have here is what's called a hiding matrix. In the process object view, each row is a separate alarm, and these columns that you see here are the potentially up to 32 different states. And you go through and you check or uncheck based on whether you want to suppress the alarm when that state is active. And then within the AS control system, we have to figure out or create some logic to indicate which state, which of those 32 states here is the one that's active at any one point in time. And there is a special block created to do that called the state rep block. So that would be laid down and then some logic connected to it to help determine which of the 32 states is active. And with that information, that would be propagated up to the ES. Now, the alarms that actually are created for the devices and the process, they go off as normal. And when they come into the OS, if they're to be impacted by the hiding matrix, then it would essentially filter them out. So the operator would not see them in the OS runtime. They would, however, go to the archive because they are alarms that occurred. So this is how you could define design suppression, automatic alarm hiding in PCS7. And then any alarm that is automatically suppressed would go to the suppressed or hidden alarm list. So you would need to train operators on going to look for alarms on this list, or knowing that they can go to this list perhaps and unsuppress if need be. So now let's look at how we might implement an alarm flood suppression design to prevent the operator from being overloaded when a compressor trips. So we have a whole bunch of alarms that we expect when the compressor trips, and they'll flood the operator. So if the compressor trips, we want to suppress those alarms temporarily. So how do we set that up? One conceptual example, we lay down our state rep block, then we define the logic for knowing which of the two states, compressor is running in normal or trip, which of those two is active. And that goes into the state rep block, which propagates to the ES hiding matrix. Now, in this case, we might want to say, well, we're going to suppress most of the alarms, but we still want the operator to know. So let's create and enunciate a common alarm instead if the compressor trip state is active. So we could do that. And then we can define the hiding matrix accordingly so that all the typical alarms that you would expect will be suppressed if the compressor trip is detected, but the compressor common alarm would be presented to the operator. And how might we do that? In the SIL alarm system, we can define the detection conditions, and they can be conditions that must be true or that can be looked at in a voting scheme. And then we can define which alarm should be suppressed. We filter the database, perhaps based on the process area. It identifies which alarms that we're dealing with, and then we can check on an individual basis whether we want the alarm to be suppressed. So this is a key difference from the area locking, where every alarm on a tag is going to be suppressed. In this case, you can choose which alarms to be suppressed. And then those would be loaded into the suppression group, and then ultimately that's going to be passed back on to PCS7. Now, one of the things that this does is it shows you for each alarm that you are thinking should be suppressed, gives you the priority, the classification, and it also tells you whether you have claimed the alarm as a safeguard or an independent protection layer in the SIL alarm database. Because if you have, you might say, well, we should not suppress those alarms, or we need to do more due diligence to make sure it's acceptable to suppress. Anyway, so we've defined the design for how we want that to work in SIL alarm. We can extract that into a design spec that someone could take and then implement in the PCS7 system with this information. And we can extract some of that configuration to an Excel spreadsheet and then import that into the process object view, hopefully defining the hiding configuration, which boxes should be checked and which ones shouldn't be, based on automatically defining that in SIL alarm. So this would help you not only define how you want the suppression to work, but actually help you kind of automatically configure it from your design spec. So now if we look at all those different non-operational scenarios, we can see that the suppression tools and things that we just talked about provide us an opportunity to help deal with those scenarios in a different and better way. And PCS7 has the ability to support all of these particular functions. So now, finally going through the last couple of steps just for completeness here, monitoring and assessment of alarm system performance. Same tools that we talked about earlier would be relevant here. In terms of the process, this is much more the tools identifying which alarms are not working and then going through the rationalization process to fix them. So definitely where you see the continuous improvement element of alarm management. Last step, auditing and enforcement. If you put a lot of time into rationalizing alarms and defining their expected configuration in your master alarm database, then every so often you should audit or compare what's in your master alarm database versus what's actually running in your PCS7 system to make sure that they're synced up. And if they're not, it'll detect what's different and present that to you for you to decide how to deal with that, whether you want to force the original value back into PCS7 or whether perhaps there was a change made via MOC that somebody forgot to update the master alarm database. You know, there's lots of different potential causes for that, but this is a way to help maintain the integrity of the alarm system configuration. So, summarizing, a lot of capabilities we looked at and discussed for helping you get the best out of, or the most out of, your PCS7 alarm system. So first, think about what priority method is best for your situation, whether you want to use the classic or user-defined. Definitely get to know and start to work with the built-in tools like the hit list, because you can use that immediately and right away to help with bad actor remediation. Take a look at the alarm message lists and make sure that they operate and behave in the way that you want. If not, modify them as necessary. You might want to consider migrating to the APL library for the advanced functionality it provides. Consider implementing alarm shelving to help operators deal with nuisance alarms. Use the loop and alarm functionality. Consider implementing alarm help, particularly if you have done rationalization or are planning on doing rationalization. Look into using the locking for individual devices and whole entire process areas as a way to help suppress alarms that are not needed by the operator and make sure that operators are trained on how those functions work and where to look to see the alarms, and consider implementing automatic alarm hiding. So a lot of different features to think about, how you might take advantage of them, how they might solve some issues that you have right now, and how they might help make the operator's job easier to do with a better performing system. And as I mentioned, training the operators on how to use these functions, when to use them, and what they're used for would be important if you want to see this drive performance improvement. So on that note, I will say thank you for your attendance, and also thank you to the Siemens team that helped with the technical questions that I had related to this presentation, especially Ronald. If you would be interested in more information on alarm management and PCS7 and some of Exeda's experience even, there's an application story linked to that on Control Magazine, and then there's a white paper on following the alarm management lifecycle with PCS7, and a brochure that talks about what's different about the APL library. If you're interested in alarm management training, some of the things that we talked about here, we have a training class upcoming for our ALM 102 class in March 8th through 10th. That also allows you to sit for the alarm management practitioner exam to show that you've completed the class and retained the material. This is a list of the upcoming courses that Exeda's got, including the alarm management one on March 8th, as well as many of these courses are now available self-paced. So to deal with remote access and on-demand when I want it training, pretty much all of our classes are available in that format as well. So now is a good time to ask whether there are any questions. I apologize that we've gone over in time here, but if you have any questions, please enter them into the questions box, and we will take a look at answering them probably via email after this is complete. Now, if you liked this webinar, and this is your first, there's a whole collection of previously recorded Exeda webinars on the Exeda YouTube channel. And there's a collection for alarm management in particular that's got, I think, more than 30 videos, previous webinars similar to this. So I encourage you to check them out if you found this interesting. And if you have any comments or questions or want to talk alarm management and talk about how we might be able to help you, please feel free to shoot me an email. So on that note, I will say thank you again for attending. Thanks for your attention, and hopefully you'll join us again in the future for another Exeda webinar. Thanks and have a good day.